We covered electrical portion. Let's go to mechanical. For that one, I'm going to introduce another case study of ours, which is the portable water generator, which has a lot of mechanical parts. So this is going to showcase our mechanical job the best. When you start working on a prototype, you need to think how each part is going to be manufactured. So before you start doing any design, so just divide your product into pieces and think about how each one of them is going to be manufactured. There are multiple ways to prototype mechanical components. I'm going to cover 3D printing, CNC machining, and silicon mold. 3D prints are typically the easiest to get, no startup cost, they're cheap and fast. Quality is on average so-so. When you want to have better quality or better look, CNC machining is a better alternative. When you carve the unit out of solid piece of plastic, it requires some certain design considerations. For example, how far the mill can go in a plastic. And there is one other option which we use a lot. It's called silicon molding, and I'm going to cover this one in detail. This allows to create really high quality prototypes without big investment for tooling. So the way it works, you do the master model, either CNC machine, 3D printed, you polish it, you really make it look nice and feel nice. Then you put it in their solid piece of silicon to create a cavity, and then you pour the melt plastic inside that silicon. This way you can create either anywhere from 10 to 100 pieces with really high quality and low investment into the tooling. Usually it's below $1,000 for small parts. And those components look exactly as the injection molded units, but you don't pay thousands of dollars for the mold. Once mechanical components are there, assemble modules, this is the time to lock down on which components you're going to be using eventually. So take your time to validate things here. There are no significant changes for components after EVT phase. Assembly. We recommend doing most of the assembly in-house, so don't involve CM at this stage. Engineers who are working on the design need to be involved in the assembly. They learn a lot, they see how it can be improved, so really take time to take this expertise in-house and see how things get together. In parallel with mechanical, electrical, there should be work on a firmware. So firmware development, you start from the ground up, from how device powers up, how does the core functions, and you go all the way up to API and connectivity layer. On average, we recommend spending at least 30% of time on validation. So if it takes you 3 months to develop firmware, allocate at least 1 month for complete testing. Test everything, because engineers like to rush into production, take some time here and really validate things. At the end, it's really rewarding process. You get final EVT prototypes. They looks like final product, they work like final product. They might have some cosmetic defects, they might have some finishes differences or color differences, but they look really good and you can raise money with those. Another example of EVT prototypes for the headphones product. Sometimes it is acceptable to use NonFinal Materials if it costs too much to use proper plastic. For example, here we used simple ABS plastic instead of the composite material on a final unit for the sake of time and cost reduction. And finally, many IoT products have some sort of connectivity to either mobile app or web app, so create an MVP product here, minimal viable product. Don't spend too much time and money on a fancy application, just get the work done. Connect it, get all sensor data in the app, and go from there.